Assalamualaikum warahmatullahi wabarakatuh. We are from Group Man United and our project is the Wearable Heat Stroke and Dehydration Prevention System developed using the MIPS in the mask simulator. So the system is to monitor user body temperature, heart rate and possible fall incident. We classify to safe, warning, critical and the fall detected. The system simulates actuators including the OLED display, cooling fan and vibration motor. So we begin the first test with enter the 36 degrees Celsius with heart rate 75 beats per minute, and then it shows the condition safe. The next one we increase to 38 degrees Celsius while maintaining the same heart rate. Since the temperature exceed the normal threshold, the system change the setter from safe to warning. So the next test case is the idle state monitoring. We repeatedly enter normal temperature and heart rate, also and no fall related activity is detected. And then there is no warning message, emergency alerts or cooling fan activation or vibration notification occur in this state. Okay, we are moving to the next test case, the fall detection and false alarm prevention. In this scenario, the sudden acceleration is detected and it is immediately followed by the no movement. The system interpret this as possible fall and activate the fall detected SOS alerts. In this second scenario, a sudden acceleration is detected but movement continues afterward. Since the user is still moving, the system determine that a fall has not occurred and return to safe status. We move to the next test case, evaluate the heart rate monitoring functionality. First, we will enter a normal heart rate of 75 beats per minute, and then the system displays safe status as we expected. So the second one, we increase the heart rate to 115 beat per minute. Since the value exceed the warning threshold, the system change to status warning. Yeah, it show the heat stress status warning. Then we continue to monitoring and then enter the normal temperature, enter the heart rate further to 145 beats per minute while keeping the body temperature normal, and then display status instead of critical because our design require both high body temperature and heart rate high. So we move to the next test case. We enter extremely low values. Since the value do not certify any warning or critical condition, the system remain in the safe states. The next one, we simulate a critical heat stress scenario. We enter 39 and 145 beat per minute because both reading exceed the critical threshold. It classify as the critical, and then the critical message is displayed, the cooling fan is activated and the vibration motor is triggered. This action are intended to immediately notify the user and assist with cooling during a potential heat stroke emergency. So we still continue and then enter the 39. We provide a value corresponding to a critical heat strike condition while simultaneously stimulating a fall event. And then Although the temperature and heart rate satisfy the critical criteria, the system display fault detectors as well as alert instead. So we move to the next one. We enter this connection by entering a value of negative 1 for body temperature. The system detects the abnormal reading. Then it display an error message indicating that one or more sensors have been disconnected. And the last one, I think, the last one, we will still continue. So we demonstrate the system shutdown procedure. When prompted to continue monitoring, we enter 0, and then the program display the shutdown message and terminate successfully. So this concludes the demonstration of our wearable heat stroke and dehydration prevention system. Thank you for watching.